Hi, this is Danny Tang. I'm doing the Probability and Stochastic Processes Homework 6, Problem 2. And in Problem 2, we're given x and y are IID random variables with PDF. F of x is equal to e to the negative x, and then f of y is e to negative y. So they have pretty much the same distribution, and the problem asks us to find PDF of the random variables given below. So for part A, it's x plus y. And to do this, we just set this equal to z, and then we write this in terms of y, z minus x. And to find f of z, this is basically just convolution. So you do the integral 0 to z of the f of x times f of y. So e to negative x times e to negative z minus x dx, and you get this pretty much times z. So this is for part A. For part B, it's x minus y. And this is pretty much convolution again, when you write, set this equal to z, and then you write y equals x minus z. And f of z, you do the same thing, 0 to z e to negative x times e to negative x minus z dx. And then when you do this integral, you're gonna get e to the z over negative 2 times e to negative 2x, 0 to z. And then when you simplify this, you find that it's z e to the z minus e to negative z over 2. And that's for part B. And part C is a product, x times y. You set this equal to z, write y in terms of the two variables. So this part you can actually find in the lectures. You have to find the Jacobian. So this is just straight from the lectures. And then you find that it's negative x, and you set this equal to negative w. So this integral is actually really complicated, and I don't think you can actually solve it by hand. So it's better to just leave it in the integral form. So in this integral, you replace the w with x and z over w with y. So this is what you would get as the answer, or x dx. And that's the answer for part C. And for part D, it's the quotient x over y, so it's equal to z. And this one, you do it pretty much the same as you do it in part D, except that it's not 1 over w, it's just w. So this is pretty much just the answer. And that's it.